today we're going to talk today about another factor affecting solubility, which is identity of ionic salts. This ties into reading reference table F. On reference table F, what this really has to do with is that some compounds, even though they're ionic, won't dissociate in water because the water can't really provide the sufficient force to pull them apart and overcome their attractive charges. So what often happens is we have the formation of something called a precipitate, which we'll define in a moment. It's really just an insoluble solid. So anything that falls under a category where it says soluble is going to be obviously a soluble compound. This is going to stay in aqueous. Exceptions to being soluble would be insoluble compounds, which form we call precipitates, which are solid. Again, over here, it's a little bit weird on this table because I actually put insoluble on the left. So these will still be precipitates or solid compounds that form. The exceptions to these rules will be soluble and will form compounds in aqueous. So those compounds will not form a soluble solid that you can see that will settle out to the bottom. Precipitates, again, are insoluble solids that form in solution. So what you need to be able to do with table F is determine if something will be soluble or insoluble. So we're going to look at each of these and determine if they form precipitates or not. Typically, it's easiest to look at the anion first. With some of these, you'll see there's another way to do it. No matter which one you look up first, if you find it on the table, it will come out the same. There is one, if your packet might have an L there, that should actually be an R, that should be chromate. So make sure you make that change if there's an error in your packet. So first we're going to start by looking at silver sulfate. So I'm going to look up SO4 on table F. And find SO4 right here, which is usually in the soluble category. However, it's combined with this exception of silver, which means it is an exception. It is insoluble. It will form a precipitate. So I'm going to circle that. Next, I'm going to look up magnesium phosphate. So I'm finding phosphate. And I'm going to look and see if it's combined with magnesium. So group 1 does not include magnesium. Magnesium is in group 2. And NH4 is not magnesium. So I do not have an exception here. So this is going to now fall under my insoluble compound here. I do not have an exception. So this is an insoluble compound as well. This is kind of a weird table. A lot of students find it confusing because it goes soluble, insoluble, then insoluble again, then soluble. So you have to read it kind of carefully. Our next compound is NH4Cl. You can actually look up either one of these. So if you started by looking up NH4, you can see that that's typically soluble, and there's no exceptions. You started by looking up Cl. It's very often soluble. None of these are NH4, so that's going to be a soluble compound. It will not form a precipitate. NaOH, you can look up two different ways as well. So Na is group 1, that's typically soluble. If you looked up OH, you would next see that if it's combined with something from group 1, such as sodium, it now becomes soluble. So whichever way you go with this, no matter which one you look up first, sodium hydroxide is a nice soluble compound. It will not form a precipitate. If you look at calcium chromate, oops, wrong way. So we find CrO4 right here. And calcium is an exception, making this a soluble compound as well. So try each of the ones on the next line, and then I'll circle which ones are insoluble. So the only one on the next line that's actually insoluble was calcium sulfate. All the rest of these, especially these guys, all have group 1 ion. They're extremely soluble. If you're looking up calcium sulfate, sulfate's right here, calcium exception, making it insoluble. For calcium hydroxide, hydroxide's right here, calcium's also an exception, making it very, very soluble. Sometimes you also have to write compounds that will follow a certain rule. For example, I want to write a compound with a chromate ion that is soluble. Quick review of writing compounds. You need to write your positive ion first, and these are all ionic, so you need to crisscross. To make chromate ions, two charge, sorry. Chromate is CrO4, the -2 charge. Go back over the table. I want to find something that is soluble. So a lot of the times chromate is insoluble. I want to pick an exception. I could pick something from group 1. I could pick calcium, magnesium. I could pick ammonium. I'm going to write a couple different ones. So I'll write one with magnesium. Magnesium is nice to pick because its charge is +2. So when you crisscross this, you get MgCrO4. No crazy crisscrossing because things canceled out. If you choose a group 1 ion like sodium, when you crisscross, you're bringing that 2 down, so you get Na2CrO4. And then again, there's some other ones you can do. Those are kind of two simple, straightforward examples. We want something that is insoluble with that same chromate ion. We need to pick something not listed over here, so we got to avoid group 1, we got to avoid calcium and magnesium, no ammonium. So if you want to pick something with a +2 charge, that makes your life easiest. I would go to group 2. Oh look, there's strontium. Not an exception. It's going to nicely just be SrCrO4. You can pick something like aluminum, for example, which has a +3 charge. You are going to have to crisscross this bad boy. You need parentheses, kind of a lot going on there, so it's sort of easier to pick something whose charges will cancel. Are there any compounds in group 1 that are insoluble in water? The answer to that, we don't have any exceptions to this rule. Group 1 compounds are extremely soluble. So no,